Hello, this is Mrs. Myers, and today we're going to be learning Section 2.5, Reasoning in Algebra and Geometry, where we will start to really learn the building blocks for writing proofs. It says here we're going to begin by looking at the Solve It on page 113. I'm actually going to let you discover a little bit about this textbook yourself. If you log into the online textbook, and you go to where it says Interactive Digital Path, you should see something similar to this page. We're in Chapter 2, so I'm going to push Chapter 2. And you get all of these options. Virtual Nerd right here is, okay, is video tutorials. But what we're going to do is go to the section that we're talking about today, which is Reasoning and Algebra and Geometry. And I'm going to pick a view, and then it shows me the Solve It that is in your book. And I'm going to let you do this yourself. So when you log in yourself, you're going to push Start, and then it will walk you through that problem. It's kind of an interesting application of algebra, the problem. So let me close down out of this, and we'll go back to our smartboard. Okay, so today's lesson, first of all, we want to remind ourselves that postulates and properties are statements in geometry that we accept as being true. Statements that we accept as true are generally called postulates. We don't require proof. We just accept them as being true. So there are several algebraic properties that you might remember learning before. First of all, the addition property of equality. These are all properties of equality. The addition property of equality basically says if you have A equals B, then you can add C to both sides of that equation, because C is the same value being added to both sides. Then the equation is still a true equation. Adding the same amount to both sides keeps the equation true. Subtraction property of equality. Same idea, except we're subtracting the same amount from both sides. Multiplication property of equality. Multiplying both sides by the same value. Division property of equality. Again, dividing both sides by the same value. Notice here, C just can't be 0. It's the only criteria there. Otherwise, you can divide, multiply, add, or subtract both sides of any equation by the same amount, and it still remains an equation. Reflexive property, symmetric property, and transitive property. These are all possibly ones you haven't heard before, and we just want to take notice here that these three are also going to be properties of congruence. So reflexive property of equality, and then there's a reflexive property of congruence. Symmetric property of equality, and then there's one of congruence, etc., for transitive as well. What the reflexive property of equality says is that A equals A, or 2 equals 2, or x plus 5 equals x plus 5. Generally, just you've got the same exact thing on both sides of the equation. Same exact things repeated on both sides of the equation. I like to think of it as repeating on both sides of the equation. That R of repeat and R of reflexive reminds us that reflexive means repeat the same things on both sides of the equation. The next one is the symmetric property of equality. Sort of sounds like symmetry. Basically, this says you can switch. If A equals B, then B equals A. It's sort of symmetrical. If we draw a line of symmetry down the middle, right? A equals B, B equals A. I like to think of the word switch. Switch the order. S of switch is like S of symmetry, symmetric. The transitive property of equality says if you know that A equals B, oops, I'm on the wrong one. If you know that A equals B and that B equals C, then you can conclude that A must equal C. I like to think of an example here. If my height is the same as my sister's height, so my height, think of it as A is my height, B is my sister's height. If my height is the same or equal to my sister's height, and then my sister's height is the same as her son's height, C, then my height must be the same as her son's height. If A equals B and B equals C, then A, the first one, must equal C, the last one. That's the transitive property. That is going to be something we use a lot. So take notice of that one. Okay, substitution property of equality. Substitution, we've touched upon this before. It just says that if two things are exactly equal to each other, then wherever one of them occurs, you could replace it with the other one. If A is equal to B, then wherever you have a B in any equation, you could replace it with A because they are exactly equal to each other. Substitution, substituting into equations. Substitution property is only a property of equality. You can only use this with equations. So let's say in equations only. Substitution property. Okay, the next few might sound familiar. Remember the distributive property? When you have a number or a variable right outside a set of parentheses, where inside the parentheses there's either an addition going on or a subtraction going on, we have to remember to distribute that number from outside the parenthesis all the way through. Multiply everything inside by that number on the outside. So A times parentheses B plus C becomes AB plus AC. And then the same thing for difference, AB minus AC. So let's look at how this is going to translate into breaking down steps into proofs and in equations. So starting with this diagram, 2x plus 30 is one angle labeled here. And the other angle is just labeled x. Right now, you ought to be able to write an equation to solve for x. So I'd like you to do that now before I write it. You write it. You should have 2x plus 30 plus x equals, and since we know that this AOC is a straight angle, or you can think of AC as a straight line, then these two angles, this pair of angles, is a linear pair. So we know they're supplementary, and they add up to 180 degrees. So that would be our equation. What we're going to do here, this is going to look a little bit like a preview to a proof, but we're just going to justify our steps. If I then asked you to solve this equation, and I have asked you to solve equations like that, and you have followed these steps, now we're just going to stop and break down the reasons for each step. Justify. So first of all, how did we know AOM and MOC? Okay, AOM, that's this angle here. And MOC is this angle here. How do we know they are supplementary? Well, because we know they're a linear pair. So that reason, the justification, is going to be the linear pair postulate. It's actually not the definition of linear pair, which you may have guessed. The definition of a linear pair just describes what a linear pair looks like. It says there's a line, and there's a ray coming off of the line, and then those two angles form a linear pair. That's all it says. It doesn't say anything about supplementary. We learned a separate postulate called the linear pair postulate. That's the postulate that said if two angles are a linear pair, then they are supplementary. If linear pair, then supplementary. So it's actually that postulate that allows us to know that since these angles are sitting on this line, they are supplementary. Well, if AOM and MOC are supplementary, then the measure of AOM plus the measure of MOC must equal 180. This is just going to be the definition of supplementary. Now, this angle written in red here, we take out the measure of angle AOM, and we're putting in 2x plus 30 in its place. Because in our diagram, we're given that 2x plus 30 is equal to the measure of angle AOM. And the measure of angle MOC is equal to x. So this step where they take out the measure of and they replace it with the actual expression is the substitution property of equality. Now, we can simplify in the next step. I'm just going to say simplify. It's combining like terms. Then what do we do from this step to this step? Hopefully you guessed subtraction property of equality. And then what do we do from this step to this step? Hopefully you recognize division property of equality. So in every case, you're really just asking yourself, what is justifying the next step? How did I get from this step to this step? Well, it's because I knew that I could substitute. How did I get from this step to this step? Well, it's because I knew the definition of supplementary. So in every case, you're asking yourself, how did I get from one step to the next step? Okay, so this box from the textbook talks about the properties of congruence. Notice on the page, on the other side of the page, I highlighted reflexive, symmetric, and transitive property of equality so that you could recognize that those are the three that are on both lists. Reflexive, symmetric, and transitive are properties of equality as well as being properties of congruence. The good news is this concept doesn't change. Reflexive property is still reflexive repeat. This time it's just you're repeating a congruence. Segment AB is congruent to segment AB. Same segment, same exact segment on both sides of the congruent sign. That's reflexive. Symmetric property. Same idea as equality. You can switch the order. S for switch. If AB is congruent to CD, then CD is congruent to AB. Notice these are written as if-then statements. If A is congruent to angle B, then angle B is congruent to angle A. Symmetric. You could draw a line of symmetry right through the two statements, and they mirror each other. Transitive property. Again, this is that transition. My height, my sister's height, her son's height. In this case, we're using congruence. If AB is congruent to CD, let's draw a picture. If segment AB is congruent to segment CD, these two are congruent, and CD is congruent to EF, CD is congruent to EF, well, then AB must be congruent to EF. They're all the same length. And so forth with angles. Transitive. So, in this problem, we're just asked to give the property of equality or congruence that justifies going from the first statement to the second statement. Just to get the practice in asking yourself, how did I get from one step to the next step? So 2x plus 9 equals 19. 2x equals 10. What do we do to both sides of the equation? subtraction property of equality. We subtracted 9 from both sides. Okay, so pause the video right now and see if you can do B, C, and go down to the got it and do A, B, and C here. And then put the video back on. Okay, so hopefully you can check your answers here. B was the transitive property of congruence. Remember, you want to distinguish between whether it's a property of congruence or equality. C was the symmetric property of equality. Under the got it, A was the symmetric property of congruence. D was the distributive property of equality. And C was the multiplication property of equality. Part D, what property justifies the statement the measure of angle R equals the measure of angle R? Again, that's just repeated on both sides, so it's the R word, reflexive property of equality. Okay, so let's take this last example here, and we're going to justify each statement using the given information. Given AB, ray AB bisects angle RAN. Typically with givens, they're also going to give you the measure of angle RAB equals X. Usually they don't just write it in the diagram, they actually state it out in the givens. And the measure of angle BAN equals 2X minus 75. Usually that's all in the givens. So when this is going to look a little bit like a proof now. First statement, ray AB bisects angle RAN. We could also put our added givens here. RAB equals X and BAN equals 2X minus 75. And that's the reason is just given. They told us that. Now we can say the measure of angle RAB equals the measure of angle BAN. Why? Because of the definition of bisect. Cut into two equal pieces, two congruent pieces. Number 3, X equals 2X minus 75. Well, what changed from here to here? They changed the RAB to an X. Why could they do that? Because RAB equals X. So we just take one out, the other one in. Substitution. Now we're going to subtract X from both sides to get 0 equals X minus 75. So that's the subtraction property. Let me add 75 to both sides. Addition property of equality. Now what? Look what happens from 5 to 6. Which property is that? Which property says 75 equals X? Therefore, we can switch them around and make X equals 75. Symmetric property of equality. So, in general, the important thing from this section is to get very familiar with the properties of congruence and all the properties of equality, and identifying when one step leads to the next step and what the justification is. Okay, thank you very much.